And congratulations, viewers, on realizing our channel exists. We've got a coronal mass ejection warning and a solar flare watch continuing. On today's daily space weather. So here is the sun in 94 angstroms, and that coronal mass ejection came from this area right up here. And we're going to zoom in a bit on the equator here now that we've showed time and date stamps for some spectacular imagery from the Solar Dynamics Observatory. And you're going to see right ahead of this sunspot, right there, you're going to see a little explosion happening. And it has sent a bunch of plasma flying through the solar system. That and much more to come. Next, we'll take a look at the stereo A imagery, located out here at Lagrangian point 5, which puts Earth off to your right if you're viewing from stereo A's perspective. Also Mercury showing up on the imagery here. And you can see this coronal mass ejection starting to make its way out of the solar corona now. And that's why we've changed the watch to a warning, because it's currently unfolding. So let's go to Lagrange point 1, the location of the LASCO C2 on the Discover spacecraft, the SOHO LASCO C2. And we do see some of the ejecta here. This coronal mass ejection event is not complete, but we see some of the ejecta. Looks like it will likely miss Earth to the west. We've got to wait a little while here. It's too early to get really great trajectory information on that. And let's take a look at sunspots. So here's the intensity gram. We'll zoom this out for a minute so you can see time and date stamps. I know they're small and gray. We've got a significant possibility for major solar flares here. Let's actually bring up the latest image. So this is a major beta class sunspot group, this is a major beta sunspot group, and this is a major beta sunspot group. They all contain complex fields. This is a major beta sunspot group as well, and there's another sunspot rising. So here's another view here, 335 angstroms, one of the ionized iron spectra. And let's animate the colorized magnetogram. So this sunspot group down here has decayed to plage. It's located at a very high latitude. It was located at a very high latitude. It has no umbrae left. So we've got 4 beta-class sunspot groups here. And again, likelihood for large solar flares is certainly there. That's why the watch continues. Here's a diagram of the solar system in case you're wondering where things like planets are located. And there's where things will be in 1 week. Radio flux of the 10.7 centimeter variety, now up to 87 solar flux units. And that's the most proportional data set to sunspot number. There is the data on that. That's from Solon.info. This black line here is the 10.7 centimeter radio flux. And the red line underneath it is the sunspot number. So another significant ramp up here in solar activity. Expect to see the radio flux continue to rise, especially considering how many sunspots are currently on the Earth-facing portion of the solar disk. No space weather storms or geomagnetic unrest forecasted by NOAA. That's from the Space Weather Enthusiast dashboard. And let's talk about seismicity. I don't want to sound like a broken record here, but if you look at all these red bars, those are all 7+ magnitude earthquakes, and you can see how often those happen here on the volcano discovery bar graphs, and those are very useful visual aids. You can see how often 7 magnitude earthquakes happen. Well, check out the past 90 days. So there's the year to date. But if you look at the past 90 days, there is a 7+ magnitude earthquake drought going on. So if you're in an earthquake-prone zone, please be prepared for a disaster. Try to be an asset, not a liability. When buildings start to collapse, know which building facades might collapse if you're going to evacuate yours. If you don't have a bug-out bag, well, at least knowing which buildings may collapse could save your bacon. No major quakes here over the past 24. In fact, it's a bit of a lull in earthquake activity. We'll just scroll up the list. And if there's anything we miss, leave us a comment and let us know. There was a 4.1 at depth at Peru. That 4.1 magnitude quake at 125.4 kilometers estimated depth. So we saw at least a couple in the 5 range here, such as this 5.2 at the Philippines. Again, no major earthquakes here over the past 24. Pakistan also saw a 5.1. Please let me scroll. Thank you very much. All right, it's not going to scroll. I'm just going to scroll manually then. Cheers. Timor-Leste also saw a deep quake at a 5.1 magnitude. It's an earthquake lull. Again, there's an earthquake drought going on, folks. We implore you to be aware of this, as earthquake droughts end in large earthquakes. Let's check volcanic activity. White Island volcano on New Zealand is back on the list. We'll get to it in a minute. First, Karimsky. Reported to be exploding, producing a 9,000-foot plume of volcanic ash. Dacono exploding as well. 7,000-foot plume of ash there over the Isle of Halmahera. So White Island has been pretty stable here. No eruptions are really expected from it. The gas output and so on have been pretty consistent here. And a gas flight just yesterday confirmed the amount of gas being released has not changed significantly over the past few months. It is venting steam and gas. All right, and continuing on the list here, Fuego exploding, producing a 15,000-foot plume of volcanic ash over Guatemala and fertilizing the downwind region. Sangay, 22,000-foot ash plume over Ecuador as Sangay volcano explodes. Sabancaya exploding, producing a 20,000-foot plume of ash over Peru. And Nevados de Chilean, 14,000-foot ash plume as it explodes over central Chile. Please do not pole vault the caldera. This public service message brought to you by smAsho.com. Go ahead, go to our website, smAsho.com. Pick up some merch. We would greatly appreciate it, as we put out these videos at massive personal risk and expense. Next, getting back to the sun-facing suite of instruments on the GO 16, here's the X-ray flux over the past 3 days. And we saw a couple of C-class flares there. Again, likelihood of M-class flares is certainly there. There are some major sunspots. No big spikes in the proton flux here, nothing that I would refer to as a proton event. Just some minor little perturbations there in the proton flux. GO's magnetometer showing some pretty wild swings here in the past several hours. Just after midnight, the GO's 16 magnetometer started getting some quite varied measurements here in the past, that's about 6 hours there. And let's take a look at the heliospheric current sheet magnetic environment. I would forecast here that the South Pole-oriented current sheet may be coming back our way. Don't be surprised to see us cover it tomorrow in tomorrow's Daily Space Weather video. This is the line of sight ecliptic plane field plot. The top view ecliptic plane field plot. It shows North Pole-oriented current sheet in green, South Pole-oriented current sheet in red. And here's a line of sight data for the same thing. It shows you a 3-dimensional view of the current sheet there from the Earth's perspective, also the solar magnetogram. Quite a lot of activity there on the Earth-facing portion of the disk. Here's the line of sight coronal hole plot. Basically, it's a coronal hole drought here, folks. I mean, we see some minor coronal holes here. Some of them may be hidden by those sunspots, so we'll be keeping an eye on that. And when I say ion, well, they have lots of ions and yes, charged particles. And here's your solar flare monitor. You can see there's going to be 5 regions of possible major flares here. KP index currently at 1, and for you new viewers, once again, congratulations on finding out that our channel exists. Please press like and subscribe. The KP index is a measurement of global geomagnetism. Next, real-time solar wind. Give it a minute. And here we go. Current solar wind density, 5.5 protons per cubic centimeter approximately. Solar wind speed still elevated here at over 500 kilometers per second. Looks a bit like additional coronal hole wind there. And let's take a look at the geospace. It's a geospace magnetosphere movie. It should be 4 hours of data. And it's showing you a pretty homogeneous magnetohydrodynamic pressure here. The units are nanopascals. And a little bit of an uptick there in the solar wind velocity toward the end has caused a bit of a slight increase here in the pressure around the Earth geospace. This data courtesy University of Michigan. Here are ground magnetic perturbations, geospace delta B, changes to the Earth's B field. We see some pulses coming out of the Central Pacific Ocean there. East-southeast of Hawaii. And we show this data daily as well. At least 4 hours of it. Since there is a magnetic excursion going on, Earth has 2 north poles, and the south pole is someplace in the Southern Ocean south of Australia. And once again, I would remind our viewers to press like and subscribe if you're new to the channel. Tell your friends and foes about the content, as I think the algorithms may dislike the Smash News Network, least busted name in news, probably because we're not putting out any fraud or propaganda. I think the algorithm has beef with that. And don't forget to check our playlists as well. You can find all of our videos at youtube.com/smashamash/videos. We're also on Twitch thanks to our followers over there. Consider downloading the Twitch mobile app. You'll see when we go live. We're going to do it later today. Yesterday's Cosmology segment was a separate video. So here's a little teaser. That's friend component. In any case, it's creating quite a molecularly interesting area there. That's Thor's helmet. Watch yesterday's Cosmology segment if you didn't yet. There's a playlist for it at youtube.com/smashamash/playlists. We're also on BitChute, by the way, if you weren't aware. BitChute.com/smashamash. Over 1,000 views on our video yesterday. The one about Sagittarius A, supernovae, cosmic rays, galaxy formation, our Cosmology segment. Today's Cosmology segment will be integrated into the daily space weather video. So let's blast through it. It's going to be quick. Planetary shields will buckle under stellar winds from their dying stars. Now, we've never seen a star die. We've never seen a star get born. And there's no verification that the alleged life cycle of stars in the standard concordance model of stellar evolution is even a thing. We've never seen a star go from red giant to white dwarf, or a star go from yellow dwarf to red giant, which is what mainstream astronomers believe the sun will do eventually. And if the sun does indeed do that, we would be inside of it. It would get to be about the size of Mars's orbit, something like that. And these are all based on 1800s concepts of how stars do what they do. It's one of the many reasons that cosmology is being rewritten as we speak, as there are, let's just say, lots of refutations to the standard concordance model when we start looking at things. And we just let that article scroll so that you could read it yourself. Feel free to pause the video if you like. Let's talk Hubble. The Hubble's back online. There was a software glitch with the Hubble, and now it's back. Check out this high-resolution image of a merging three-way. It's a three-way, folks. There's a three-way going on right there. Fantastic imagery there of a likely galactic merger. I would also note the way everything appears to be at a 90-degree angle here, practically. It's pretty interesting. It looks like a three-way galactic merger, though, as all three of these galactic cores appear to be interacting. Were you aware that most spiral galaxies have an even number of spiral arms? Well, this one's interesting in that it has 3 spiral arms. You can find this article on SciTech Daily about how the Hubble is back in business following its little issues. And we'll let this one scroll for you as well. Feel free to pause the video. The beauty of video on demand is that we'll be here when you get back. So thank goodness the Hubble did not go into a defunct state. Let's talk about Comet Atlas. Comet Atlas broke up, and we actually showed it on the channel. There's some imagery of Comet Atlas following its breakup. It didn't break up because its significant other wanted a three-way, no. Anyway, the solar orbiter flew through the tail of the disintegrated comet. So look for some interesting science about this coming out. Did it do a collection of the material? Well, I'm not really sure, but it apparently sensed its magnetic field and so on. Yeah, the plasma sheet in the comet tail and so on. Pretty interesting. Another SciTech Daily article. And let's talk about the Ring Nebula. That's not the astronomy photo of the day. Astronomy picture of the day, rather. But today's astronomy picture of the day is of the Ring Nebula. And you're looking at hydrogen there in pink and oxygen in blue. So this is pretty interesting. Imagery of stars versus the Ring Nebula there in different spectra. And you can see the way the stars are emitting a continuous light spectra here. Almost like blackbody radiation, right? You can see red, orange, yellow, the whole rainbow of colors. But the Ring Nebula looking a little bit differently there, showing up in specific colors. Why? Because it's got a lot of oxygen and a lot of hydrogen. So it's also known as Messier 57, the Ring Nebula, M57, from the Messier catalog. There it is in its full glory. And that's the astronomy picture of the day, the spectra of the Ring Nebula. And this gives us insight into the chemical composition of things in space. What's interesting about this one is that we see lots of hydrogen on the outskirts and lots of oxygen on the interior. Sup with that. Next, welcome to the Neo-Renaissance. Visit our own website, smAsho.com, if you haven't. Find our social media. Check us out on all of those platforms. Click on our merch. And we've got a featured merch item today once again. And you can find this one at the smAsho store. It's an homage to the pathetic and infantile response by mankind to SARS-CoV-2, the virus that causes COVID-19. Because the pathetic and infantile response included non-pharmaceutical interventions like masks and lockdowns, which are utterly ineffective and continue to be utterly ineffective and are still being touted by people like Dr. Fauci. What a fraud. And if you click on smAsho store, you can find that and other delightful products there. Also, make sure you check us out on Twitter. There's all kinds of stuff on there that's no place else, otherwise known as exclusive content. Today, we're not going to look at a random number at all. We're going to look at Sagittarius A star. It's the core of the Milky Way galaxy. And let me just cite something here. This is what's going on in the core of the Milky Way galaxy, all right? The way that the sun interacts with the Milky Way galaxy, with the Milky Way galaxy's core, is that it doesn't. The energy from the core of the Milky Way galaxy is imparted to the rest of the galaxy via the spiral arms and the galactic jets. Sagittarius A star is about 42,000 light years away from planet Earth, and it is not doing anything to the sun. It's not responsible for the sun's behavior. And anyway, here's some imagery of what's going on around the galactic core. Now, this is the Pan-STARRS optical imagery here. And if you look, you can see that there are a ton of blue supergiants. See all those blue stars? Those are very hot, very bright, very massive stars with massive outputs. But if you zoom way into Sagittarius A star, there's almost nothing even to be seen there. It's really a dark spot. Let's take a look at it in some other wavelengths here. So here is the Milky Way galaxy in X-ray. Now we're zoomed way out, and you can see the X-ray sources here line up along the disk. And when we zoom in, we'll see some more X-ray sources come into view here. And that's the X-ray source at Sagittarius A star. This is the object around which a whole lot of super hot massive stars are orbiting at relativistic speeds, hundreds of kilometers per second. And once again, this is what it looks like. You can see the years projected there as the trajectories of all these stars has been calculated. So that's Sagittarius A star in X-ray. And here it is on the 2MASS. That is infrared light spectra. And you can see the galactic disk is quite a hot place. Not a lot of detail there in infrared light from Sagittarius A star. And let's go back to X-ray here once again to close out our coverage of Sagittarius A star. There is the X-ray region at the core of the Milky Way galaxy. The massive radio source, known as Sagittarius A star. How about long period oscillations of the sun discovered? Did you know that the sun rotates at a different speed at the poles than it does at the equator? Yeah, it rotates faster at the equator than it does at the pole. What's up with that? Well, it's kind of important. And so is this article here, although there are some issues, which I won't get into. I'm just going to let the article scroll and bring it to your attention here. Helioseismicity is a thing that's going on. And I really don't have a lot to say about this one, except that there's been some models created. There have been some models created here to attempt to simulate the solar magnetic dynamo. This article is from phys.org's Astronomy and Space section, long period oscillations of sun discovered. And here's a more interesting one and more attuned to our channel. So what about stealth coronal mass ejections? Were you aware of this? There are even things called ultra-stealth coronal mass ejections. And what this imagery is showing you here is 193 angstroms views and then difference imagery. So this imagery here, these are all difference images. And it's showing you things like darkening spots. That's one of the ways that we see coronal mass ejections is by limb darkening. And some coronal mass ejections are very difficult to spot. And that's what the article is largely about. And really, this isn't going to be too groundbreaking to any of our regular viewers. To many of our new viewers, you may want to press subscribe to the channel, as I'm pretty sure nobody else in the world is capable of forecasting coronal mass ejections. Our channel, however, is, which is why we've been doing it with a 100% success ratio for the past several months here. So, several months of perfect forecasts on coronal mass ejections. Keep in mind that we only forecast coronal mass ejections on the Earth side of the sun and around the poles, not on the opposite side of the sun. Again, make sure you check out yesterday's Cosmology segment if you haven't. This is part of the imagery from our thumbnail yesterday. And again, you can find all of our playlists at youtube.com/smashamash/playlists. Our Cosmology segments have over 200 videos, so go check them out. And that's today's Cosmology segment. Let's continue on talking about electrons. And we saw some charging hazards when we did show prep, but they have now dissipated. No charging hazards around planet Earth right now for our satellites. The electron flux levels aren't particularly high. They're just in a moderate range. Here's the one-year chart from Solon.info. Here is the 3-day chart of relativistic electrons. The greater than 2 mega-electron-volt electron flux, measured by the GO-16. Nothing to write home about there. Here's the forecast model, expecting a little uptick here in the electron flux, and I would tend to agree, as we currently see an elevated solar wind speed. Here's a diagram of the atmosphere, including the Van Allen belts, as well as distances in miles. Yes, GPS satellites are located at about 12,500 miles of altitude. And here is the total air column. So this is the total electron content for the whole air column, and we're seeing some anomalies once again. Apologies to our viewers for not showing this yesterday. We did put a community post up on YouTube about that. And right in here, south of the Atlantic Ocean, you'll see an anomaly right there. So that's a little bit of a miniature Van Allen belt essentially forming there. The real question you have to ask yourself is, did those electrons come from the sun, or did they come out of the Earth? Or were they just redirected? Were they already in the Van Allen belts? Where did those electrons come from? And why did they go to that location? Probably because of magnetic fields. Electrons are only about 1/1800th the mass of a proton, and the electron flux gives us insight into that. That's why we cover it. It is a little bit chaotic right now in terms of the electron flux. This will give you ideas of where GPS errors are most likely to occur, as your GPS unit has to communicate through large blobs of electrons, which cause massive errors. Anyway, that's a total electron content forecast. A little bit of chaos going on once again today in the earthly electron flux. Next, we're going to show you the F ionosphere layer, the ionogram, located at about 300 kilometers of altitude. Give that a minute to load. And there we go. There's the ionosphere. This data is provided by Australian Government Bureau of Meteorology. And each colored blob here represents 1 million vibrations per second. Quite anomalous here in the ionosphere. We're seeing areas surprisingly high vibrational frequency, like right here, Central South America and the West Coast, and also surprisingly high vibrational frequency way up north, once again here over North America. Right in there. But this is the bigger anomaly here, this sudden high frequency region forming right in there, just west of the South Atlantic anomaly. So there actually are two anomalies right now, folks. There is a South Atlantic anomaly, which is right about here, and there's a South African anomaly down here. Those are the two weakest spots in Earth's magnetosphere. Here's the latest image on your ionogram, 9:15 Universal Time. Things looking normal at that moment. And to our space weather enthusiasts, don't forget to check out our meteorology segment as well. It's got a playlist. Here come our bonus features. Bonus feature 1. The hydrogen alpha imagery from the ground-based observatory at El Teide, Spain. Remember, folks, there's a coronal mass ejection watch in effect. There's a warning in effect because there's one propagating now, but there's also a watch, and there's a solar flare watch for large solar flares. Don't be surprised to see an M-class flare, which could release all kinds of additional coronal mass ejections. Here's the latest intensity gram. And quite a few sunspots. You see this one down here. That's beta class. That's beta class. That's beta class. And that's beta class. Also, that's beta class. So there's your 5 beta class sunspot groups, all capable of producing significant flares, including indeed M-class flares. You can see an X-class flare. It's possible. And keep in mind, folks, especially with respect to this one here, I mean, these are pretty likely to produce major flares. This one is the most likely to produce major flares, in my opinion. It's got the most complex magnetic field scenario going on. Here's a close-up of it. And you can see we've got pretty equalized fields here, although the South Pole umbra, there's more North Pole than South Pole umbra. I'll just say that without muddying the waters. That one's pretty complex too. It's got mainly North Pole umbrae. And oh, there's a new sunspot group rising here, and it looks huge. Look at how huge the field is leading this. I don't think we see any umbrae from that yet. Let's check. And indeed, I don't think see any umbrae from that yet. So that could be another sunspot rising. Again, don't be surprised to see the radio flux and all kinds of activity kick off in the next couple of days. Here's the NASA GOES 16 SUVI map, and you can see there are lots of filaments here in between the Earth and the Sun. All these dark orange, these reddish-orange regions, those are all filaments, and there is a massive ability for those to be released, especially with the number of beta-class sunspots we've got. That's why the coronal mass ejection warning is in effect, and the coronal, the solar flare watch is in effect. And we'll close out today's daily space weather video in this composite imagery. This is 171, 193, and 211 angstroms, which are all ionized iron. And you can see the way those different spectral states behave quite differently. And we'll zoom out here so you can see the time and date stamps. Once again, thanks for tuning into the Daily Space Weather. Congratulations on realizing our channel exists. And may that solar wind be at your back.